Hello guys, welcome to the next video. So today we will be performing how to inject a reverse shell, a payload, a shellcode of reverse shell into an executable file. So I will be choosing a putty executable file to perform this specific task, and we will be generating a payload from MSF Venom. So first we have to understand how this thing really works. So as in my last video I told, we are simply hijacking the entry point, redirecting to our code cave address, performing the malicious task. In this video it will be a reverse shell. Sorry for my bad handwriting. I'm using mouse, and we will simply give the code flow execution back to the its original place. So first let's generate our payload. So I will be using this command for specific windows: msfnm windows shell underscore reverse underscore tcp, and this will give me a hex input. So I'll give this shellcode as an input in my putty executable. And first let's copy this code. So as you can note, this payload is of 324 bytes, and we have enough bytes. I added 1000 bytes in my last video. I'll be continuing with the same putty file. So let's open putty file. I'll open the initial putty hello. So as I clearly hijacked the initial entry point to my code cave address. This is my code cave address. So for new viewers who did not watched my previous video, uh, I added a new section in my putty, namely .hello. So the section is at address. You can, if you can see, 0051A 0A triple zero. So I'm simply redirecting the entry point to my code cave address, and I'll be pasting the reverse shell code to my code cave section, and then giving back the code flow execution to the initial point. So let's go to the code cave, press F7. So this is from my last video, and this will be my second video, of course. So let's change all the operations to knobs. I'll be selecting many instructions, and I'll be filling with them with knobs. Now let's leave some bytes above. I'll paste push ad, push fd, then my shell code. So let's select enough byte for our 324 byte shell code. I guess this much will do work. Go to binary and binary paste. I have to paste it in a hex binary. So I pasted that. So this part is my shell code which the MSF Venom gave to us. So for this video, I'll be following uh, red team notes. So this is a very good source. You all can see backdooring PE files with shellcode. So as you can see, we generated the shellcode using this command. Oops, I missed this. I did not add the IP address and the port. So let's get back to MSF Venom. rerun our command lhost. So for lhost, I'll be giving my Kali machine IP address. So let's find that. So my IP address is .80.134. So 192.168.80.134, and my L port will be, for this case, let's keep it 565. Anything. Let's generate a new payload. So again, the payload is of 324 bytes. I'll copy it simply and go back to my Windows machine. First, I'll replace the initial shell code, and also I have to change the pasted one here. Binary paste. Yeah. So getting back to the notes, we already made the new code case section. Already gave it to executable. Inserting the shell code, I already did that. Okay. So let's save this and see whether we are able to get back a reverse shell or not. So I'll give it name reverse. I'll start the debugger again. I'll open the reverse one file. So I'll open my Kali side by side. So as I gave port 5633, and I also want to check that my, okay, yeah. So NC 56, oh, it was 4333. Okay. So let's open our PuTTY. So this is my file. Let's open it. Just taking some time. The file might even get crashed. I don't know. Okay, so we get the reversal. Okay. I don't know, it is taking a few seconds, maybe because my network issue or something like that. But we are successfully able to get the reversal back. What happens when I close this reversal? Let's see. Nothing is happening. But I want to get back to my PuTTY configuration window. So let's do it one more time. It is taking some time, a few seconds. I can see from the command prompt using netstat -eno. So currently no, before opening the shell, before this thing pops up, uh, no foreign address is being contacted. But as soon as the reversal pops, this foreign address is being added, and the state is established at this address on port 5633. If I close this shell, like we can see it again. So as you can see, there are no foreign address on which our connection is being established. So coming back to the code flow redirection, let me open it again. Yeah, press F7. Now the thing is that if we follow the notes, we have to make a few changes in our shellcode in order to perform the reversal popping and our configuration window opening simultaneously. So first we have to note the ESP value, and check the stack difference. So what is happening is, uh, the thing is that when I am redirecting from entry point, let's for example, the stack value is uh, just a second. The stack value is 101, or okay, 101. When I uh, insert any shellcode or any stuff like that, the problem is that we don't know what the shellcode is doing with the stacks. So we have to manually adjust the stack pointers by calculating the mess it had made. So our approach would be note the ESP value, the ESP register value at the initial point. Then again note the ESP value at the final point. Subtract both, and we get a certain value for, in our case, 204. Then at the end we'll simply add this ESP value, add this 204 value to our ESP register. So what will happen? It will simply restore the stack uh, to our initial point. So the mess the shellcode makes, we are just restoring that. If we do not perform this task, uh, our code will crash. So coming back, also there is a certain thing we have to do, is we have to change this value, uh, decrease ESI register. So I'll tell you the reason. So the thing, what is happening, if we want the shell to open simultaneously, and if we close the putty, and we don't want our shell to close, so what we have to do is make certain changes, by which if any user even close the putty, our shell, reverse shell does not close. So it is just a simple persistence mechanism. So what I'll do, just a second, go back to putty, and the ESI value. So we have to find the last ESI value, which is at address 0051824. So we have to change from this section. So what I'll do, I'll click spacebar. I'll convert this instruction to knock. Then I'll convert this push ESI value to push 0. So what will the this 0 does? It will set the so a window socket opens and it continuously listens. So the thing is, when we close the putty configuration window, this connection also closes. The ESI value, uh, it changes to any negative value, especially in our case -1. So I'm just simply push 0. So it will infinitely listen, or it will be infinitely pinging to my Kali machine, even if the uh, putty configuration window is closed, or any executable file is closed. Now, in our case, my executable file is push putty. So I made these changes. So now, so now, first let me read some notes. So what this person is doing, overwriting 5 byte instructions. So this is the we will do this task at end. Patching the shellcode, patching wait for single object. So the thing is that uh, in our case, only a single thread is being used. Uh, a single thread is being used. Uh, That's why we are not able to see putty window and the reverse shell in my Kali machine simultaneously. In order to do that, what we are doing, we are changing the ESI value to 0 so that it waits 0 second before unblocking the UI. So when my reversal pops up in a normal case, the UI will be staying in the background. The this this function will keep blocking it. As soon as I close the reverse shell, it will unblock the UI and I will be able to see the putty window. So let's perform that. And and now we have to restore the stack frame and jumping back task. So what I'll do, I'll go back to the normal window. First I have to save this, copy to executable selection, save file, and I'll simply save it to, okay, this putty reverse 01. Again start the debugger. Let's go back to our code cave. I'll put a breakpoint at this. So at 0051A 00B, which is the instruction FC. So at this point, our shellcode is being start. So what I'll do, I'll set a breakpoint at this address. So let's run our code and uh, keep our focus on the ESP value. So let me press run, and yeah, so you can see it has become a kind of red and black. It means a breakpoint has been achieved and code is stopped, and our current ESP value is 0012FFA0. So I'll copy that and keep it in my notes. So it is the initial ESP value. Now I'll set a breakpoint. First I have to remove this breakpoint. Now I'll set a breakpoint at the end of the code, which is at call EBP. Yes. Again run it. Okay. Looks like my it has achieved. Okay. So yeah. So as we were able to set the entry point or the breakpoint at the end of the our shell code, what we will do, so here's a trick. If we tried in this case in the starting, if I set the breakpoint and I simply run the code, and the pointer when it reaches our shellcode initial address, it stops, and I noted down the ESP value. Now the thing is, when I have to perform the same task in our end of the shellcode, it will not happen, simply because the code is written in order to uh, connect a reverse shell. So what I have to do, when I set a breakpoint here, I also have to start listening in my Kali machine. So again, I'll run that code. So in background, my Kali machine is actively listening. Yes, and now we have achieved the end of our shellcode. And the ESP value is this. Modify ESP. This is my ESP value. We'll note it. So yeah, simply. Now we have to subtract these both values. You can use any tool or any online site, or you can manually do it. We'll get the value of 204. So what this signifies is this particular shellcode disturbs the stack arrangement or stack frames by 200 bytes, 204 bytes. So what we will do, according to our notes, we have to add this section, ignore this part, uh, by replacing the call EBB function at the end. So what I'll simply do, I'll click the space bar and I'll type add ESP colon 204. Then I'll pop the FD register, pop the AD register, and a thing to note here is that if we do pop FD and AD without this add ESP line, our stack frame pointer will be not aligned. So that's why our code will crash. Now if we simply perform this task again, our code will run in a smooth manner. But again, in order to open a putty configuration window, we have to return the code flow execution. So what we will do, we will again call this part, and then again after that we will jump to our section. So I call this and jump to my initial address, which was this assemble. Now I'll save the code, copy to executable selection, and save the file. So I'll name it as reverse 2. Yeah, it is saved. I hope so. Yeah. So in the background, let's do one thing. Uh, we won't be starting the netcat in the background in Kali. First, we will open the reverse shell, the putty file. So as you can see, it is uh, loading because it is trying to find the uh, open netcat connection to our port 5633. So let's start that again. Will start the command prompt. Okay, so there's one connection. Yeah, as you can see, the foreign address is being shown here, but the state is close wait. Okay, so what I'll do, I'll simply open Windows side by side. So it is currently actively listening. So I'll open my reverse shell. Yeah, so my putty is open perfectly fine, and I'll be getting a reversal just in a second. Yeah, there we go. So in this video, I demonstrated how you can inject a shell code. So it is not that simple that you can just copy paste the payload from MSFNM, paste it inside any executable, and make that executable malicious. For doing certain things, we have to dive in the basic and depth of the code. As in this case, we had to uh, realign the stack arrangement and also change the decrease ESI value in order to open the shell code, the reverse shell, and the configuration window side by side. By following similar steps, we can also do the same thing for the Windows 11, but uh, in Windows 11 this shellcode won't work because it will be easily detected by the defender, because MSF Venom has uh, the older payloads which are being stored in the database or the defender of the Microsoft Windows, and they have a specific signature. So as soon as I try to run this thing in my Windows 11, it will be get flagged, and it will be flagged under the metripread session or a reverse shell, and it will be flagged malicious. So thanks for this video. Until then, bye bye.